Okay, so I don't have to gesticulate in this question, so you don't have to look at a little inset of me flashing signs in this corner. So, uh, this is the what's this question? Which question? This is number 2. So this is the table. So again, this is where you like kind of do things out of you're looking at things sort of out of order of the steps. So up here you have the like I'm going to call it the middle. There's several steps, but like there's 3 big steps: getting the business rules, making the diagrams, and then actually implementing the tables inside of a database. So each one of these big squares should become at least one table in the final database. And in this case, you got 2 that become 3, right? Because regardless of whether you make the little middle step we did in the other video where we have the vehicle underscore service bridge entity, you have to put 3 tables in. You have to implement the tables in that database management system as if to reflect that diagram that we made before. So this is a middle step. And this is here you're starting with the last step and asked to do some analysis from that last step back in time. So one thing you do is you identify sort of some of the parts of the tables by interpreting what's in the tables. So again, when I say tables, tables are what you have in the database management system. That's what the entities become in the final, like the entities that you have in the ERDs and entity relationship diagrams will become tables. Some set of tables in your final database with rows and columns. So each row is a record of an individual entity of that individual instance of that entity. So an individual painter or an individual painting is each row. And the columns will be the attributes of those. So the painter's name or his painter ID or maybe where he was born. I don't know. I can't remember what's in the table. It depends on what you needed to do for your business rules. But so what we're doing here is we're taking the end result kind of and going backwards first to find out what the some of the pieces were, and then from that figure out what the business rules must have been, and then we're drawing the middle step, the ERD. So we start at like 3, then we go back to kind of 0 and 1, and then go down to 2. So just being able to go backwards and forwards in time can help you kind of understand how all this works. Is the idea here. I didn't make this test originally. I probably need to modify it a little bit over time, but I think it is a good example. So here's the tables. So you can imagine these tables actually exist in a database. They'll look very similar to this, but not exactly. And I think it was a little tricky. I don't like make tests to be tricky, but I didn't think it was tricky enough to be mean. So when you're asked to fill out this chart, one thing I do want to do in the future, though, I need to make a note about this, remember, is like say that you don't have to fill in every box. You could have put not applicable maybe, but I want to make sure people know that they don't have to put an answer in every one of these boxes. But what you're asked to do first is to determine the primary key of each table. Now, it's possible that 2 columns put together could be a composite primary key, but that's not true of any of these tables. So what you want to do to figure out whether something is a primary key or not is to look at each field and determine whether it's reasonable. And even from this data, actually, I say don't try to like make speculation of outside of what's actually in the data here. So even if you look at the data itself, you can rule out first name as primary key because George is here and George is here. That's not entity integrity if that's the primary key. You can't necessarily rule, no, you can here too. So this is nicely designed because rice repeats, right? That's not unique, cannot be a primary key by itself. You could argue that the combination of 2 of these together, because I think there's an Anna rice and there's a Luann rice. Both of them are like, it looks like, what's her name? I can't remember right off the teacher I replaced, but Burlingham. She might have been an Anne Rice fan because those are both Anne words that are not exactly, vampires, whatever. So, but the combination of each of these put together could be a composite primary key that would give you entity integrity. But it's not. You can also see that each one of these values is unique and it's called ID. So if you'd said painter ID, George Birch, if you said painter ID plus first name plus last name, I'd have to debate whether I would count that wrong or not because a primary key is chosen from all the key candidates and the combination of all three of those would be entity integrity. Another way to look to see if a table has integrity is if you look at every column of every row, and there's always something different from row to row, and no two rows are exactly the same, then you have entity integrity for sure. But I think it's pretty obvious that the painter ID is the primary key. The tricky thing is that painter ID was not put first. And whenever you create a table, which you're doing now, or about to do soon, depending on when you watch this video, in the Oracle server, you do some create table SQL. So that's that last step where you create the tables, what you've got here. Usually you put the primary key as the first field listed, but the order doesn't actually matter mathematically in a relational database. So any of the columns could be the primary key. So in this case, painter ID is the answer for the painter table. That's the foreign key that's the primary key for painter table. So again, just validate before you make that as an answer. Even if it says ID, validate that each of these values is unique in that column. Same for painting ID. Again, it's in the middle, which is kind of tricky. So painter ID is a foreign key actually, but you notice it's not unique, 3030. So it can't be, like, even if you kind of got misled, you know it can't be the primary key because primary keys have to be unique across the rows. So there's 30 several times, a couple 70s in a row here. So you know that cannot be the primary key. But if you look, once you look at painting ID and you're like, okay, I think that's the primary key because it's called painting ID, just verify that every one of these IDs here is unique. Each one has to be, see, this is very close, but the 5 and 6 are different. So that's still unique. So once you pick that one and decide that it's unique by itself, that could be the primary key. And that would be the answer for the painting table. Painting ID is the primary key. And then for gallery table, this is where it's a sensible place on the left-hand side, right? Just look at, it's called GID for gallery ID. Just verify that every one of these is different from each other across the rows. And if they are, then it could be the primary key. So that's the answer to the first three. Wish I could have a short hotkey to get back up here. But so yeah, painter ID, painting ID, and G_ID. That's the answers here. Now foreign keys, this is where not everything has an answer because this table doesn't have any foreign keys. So the painter ID, these two things right here are just they're the first name and last name of that painter who's identified by that unique value of 10. And the gallery, does it have any foreign keys? Well, you've got the gallery name. That's just the name that goes with the ID. The address is just the address that goes with that ID. The city is where that gallery is, state zip. So no, so those two don't have foreign keys. So what you want to do is leave these two blank, the leftmost and the rightmost. But the painting table does have foreign keys. So the painting ID, notice it says GID. Well, that's a clue, right? If it says ID, so you know they're foreign keys because they're not the primary key. They're not unique, right? As a matter of fact, this is null. Primary keys cannot be null ever. So this has no value. That's technically, that's what a null would look like if you were printing out the results from a query. So no, in other words, painting 15405-9, which is called City of Bones, is presently not in any gallery, is what this means. But LB, a couple times, it's an ID and another. So how do you know if it's a foreign key? It's the same as primary keys in another table, and it's not the primary key here. I mean, it could be part of the primary key. Probably won't be the primary key. There's a very small example that would be different from that, but you notice this SSS. So what we're saying is that Misfit Victory is in Sister Smithsonian, and so is Pipe Dreams in Sister Smithsonian. Blah 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 blah. So this is the many side, right? So this is the one side. Each one of these, each gallery could have several paintings in it. So this gallery, Sister Smithsonian, has at least these 4, I guess, 5. There's a 5th one. So that's the many side, and you can see that it's a foreign key because every foreign key over here appears over here somewhere. Now I don't know if that's actually true because I think PH is PH not over here. So that's a later question. So, but so put that on the back burner. But this is the foreign key, gallery ID. Same for painter ID. Each painter can make many paintings. So painter ID number 30 does Haunted Farm and City of Bones and Vampire in Paradise and Blood and Glory. Who's painter number 30? Yeah, Anna Rice. So and you can see it's like she's doing an homage. Sharon Burlingame is doing an homage to Anne Rice with that, because these are all horror, vampire, and so. So the answer for this table that you're filling out is painter ID and G_ID. Those two together are foreign keys in the painting table. They're not any part of the primary key like the last one could have been. They're just why? Because the painting ID is the primary key here, and then the foreign keys are. So each painting ID will be in some gallery and be done by some painter. That's why the foreign keys are here. I'll just say really quick. The answer to this one is really the answer to the first one. We have primary keys for each one of these tables, so that means we have entity integrity. Why? Entity integrity means that you're able to uniquely identify each record as an individual instance of that entity. There's no duplicate records in your table. If you have a primary key, then you have entity integrity. It's that simple. So yes, yes, yes. And explain briefly, you would just say every table has a primary key. Well, you'd say this table has a primary key. This table has a primary key. Yes, this table has a primary key. That's all you'd have to say for this one. Does the table exhibit referential integrity? I took a lot of answers here. You could just leave it empty. I'd have to refer to whether referential integrity is ever involved when you don't have foreign key relationships between the two. Like if you don't have a foreign key in your table, does that mean you have referential integrity? To me is the many side. So let me show you why. So if you put yes or left it blank or whatever, not applicable on these two, gallery and painter, I would have counted it right. The main thing I was looking for is to see if you put no for painting, the middle one. So no, that was the most important answer on this row. So it does not demonstrate referential integrity. And let me show you why. This is the concept you want to know going forward. And that's kind of why I'm going over this part of the midterm, because these are the important things you want to remember. Let me find it. So the way you know it doesn't have referential integrity is because if you look at these foreign key columns, what you want to look for are any foreign keys that are in here that don't appear in the parent table. So you want to look through all these gallery IDs and see if there's a gallery ID here that doesn't appear up here. So so the pH actually doesn't matter. I was saying something about that, but it doesn't matter actually, because that just means that pH has never got any paintings, and that's okay. But what you want to look for, and what is it? Let's see. KN is here, and this is how you kind of have to do it. LB is here. We already did KN. BB is here. It's the first one. KX. All right. So you see, there's no KX. That's a violation of referential integrity. In order to have referential integrity in this table, every foreign key you have must appear as a primary key in the parent table, in the table that you have a relationship with on the one side. So you're on the many side. Look to the one side and see that every value in this column appears somewhere over here, right? And only once, really, because it's the primary key. So there's no primary key called KX. That's a violation of referential integrity. So that's just one example, and there's also an example with the painters, I think. So painter number 2, that's the one I saw first, actually, because it stands out, right? Everything else is a power of 10, a multiple of 10, but not a power of 10, a multiple of 10. But this one right here is a weirdo. Now, that's not what makes it a violation. As long as there was a 0-2 up here, that would be fine, but there is no 0-2. So there's a 0-2 here as a foreign key, but no 0-2 in the related table where that foreign key should come from. That's a violation of referential integrity. Where you're going to see referential integrity come up is if you enforce it. What that means is that you have to delete, say, for example, you wanted to get rid of George Birchfield because he's been canceled on Twitter, right? So you want to get rid of all of his paintings in your database. He's not a good example, actually. Let's say Anna Rice. I could see her getting canceled, actually. So Anna Rice gets canceled. If before you can delete her from this table, you have to keep it referential integrity working, and your database management system can enforce this, and it won't let you do it. It will not let you delete Anna Rice until you delete all these paintings by Anna Rice first. So you would have to delete this row, City of Bones, and then Blood and Glory, and Haunted Farm. Once all those are gone, then you're free to delete Anna Rice. But if you just try to go to this table first, and this is where you use delete from in SQL later, you'll learn how to do this. You say delete from painter table where painter ID equals 30, and there's 30s down here in the related table on the many side, then it'll say you can't do that because of referential integrity. So again, first you have to delete all the references down here, the foreign keys, and then you can delete. I mean, you don't have to delete the rows either. You could just assign Haunted Farm to another painter. You could say, okay, you could lie and say Connolly did it, or you can if it's null, if the foreign key's nullable, it allows nulls. Like for example here, this allows nulls. There's nothing wrong with that. That's no problem with referential integrity. You're just saying that City of Bones is currently not displayed anywhere. So if you changed all these, painter IDs to null, which doesn't make sense, right? Because a painting is going to have a painter, so it doesn't make logical sense. And so it's something you probably wouldn't do, but in terms of database mechanics, you could do it. If you turn those all those painters that are 30 to some other value or null, if null's allowed for that column, then you can also delete her. But the other place where this comes up is that you have to create these parent tables before you can create this. Not create necessarily, but when you add data. So you can't add Haunted Farm until you have Anna Rice in this table first. It's the other place where referential integrity comes up. So I know I'm going into a lot of detail, but the reason why these things are important, I'm telling you on top of the answer. So referential integrity is important because your data is going to get, like you have paintings that don't have painters. Like that doesn't make any sense, right? So if you have referential integrity, you have to put Anna Rice in before you can put any of her painters down in her paintings in this table down here. I kind of hate that it's painting and painter. I don't want to say artist, but it makes sense, but the words are too close together. So I keep getting them confused, and some of you guys probably did too. Okay, I started before I meant to. I'm editing here, so there's some stuff I talked about I cut out because it was going down the wrong path. I left out the ERD for the painting and all that stuff, so I'm going to do that now. Let me find it. Actually, before we do that, we need to talk about the business rules. So what are the business rules? So judging from the data we have here, and again, you want to base all this on what you actually see. Don't try to not make too many suppositions about what you see. Base it just totally on what the data says, or what the data say, if you want to use the proper grammar, because it's plural. But anyway, what are the rules here? So you can sort of start anywhere as long as you get them all right, like you get them all in there. So it just depends on how the spirit moves you. But I don't know, if we can look at the painter table, and again, some of you guys added in some extra stuff. When you're talking about business rules, you're mainly talking about the relationships. You could talk about individual things like each painter has a unique ID, but that's kind of obvious, almost like a tautology, because everything in your database management system is every entity instance is going to have a unique ID of some kind. So you don't really need to do that. You could talk about like the first name and last name, but the things we're looking for is about the relationship. This is the right answers I would have looked for. You have to have these things anyway for it to be correct. And if you had some other observations, I usually just they didn't really matter too much. So what you would notice is that each painting has one painter. That's a rule. So each painting has one painter, and it must have a painter according to the data. That makes sense in real life too. Again, like how a magical painting that nobody painted, it just kind of appeared one day, like the watch on the beach analogy kind of thing, right? That doesn't make sense in real life, but it also doesn't make sense in this data, because every painting ID, every individual unique ID, primary key, every row has a foreign key on it that's got a value from the painter table. So 30 here, 50 here. There's none that are null. So what you can determine is that each painting has one and exactly one painter. That's a business rule. And then you can say each painter paints how many paintings? What's the answer? This can get a little bit more iffy. Now, you know it's possible that he can paint more than one, but what is the participation? Are there any painters here that haven't painted any paintings? So 10 is down here, right? 20 is not. It's 20 not. Yeah, 20 is down here. 30 is, and 40 is, and 50 and 60. So all these painters have at least one painting in the painting table. I'm going to say it's a one-to-many mandatory relationship. So each painter will have one or more paintings. Each painter will have painted one or more paintings, if you want to use a better, more descriptive relationship verb. Each painter paints one or more paintings in this system that we're modeling here. Now, it is true that 0-2 doesn't exist, but like all the painters who do exist have at least one painting. So 0-2 is a referential integrity violation. So we can assume that he has at least one painting too, because Blue Skies is here. Once you put him in the table up there, it'll still be one, at least one, and maybe many paintings. Each painting is displayed or held or whatever you want to call it in 0 or 1 gallery, right? Each painting is in 1 or no gallery. So that would be a optional 1. And each gallery has, if you look down here, PH doesn't ever appear here, right? So each painting has 0 or more paintings in it. Based on the data that we see, we have to allow that some galleries are empty. Why? Because PH is empty. PH never appears here. So PH is empty. So yeah, again, each painting, oh, have I done this one yet? Each painting can be displayed in 0 or 1. Yeah, I did. So it's this one's null, but if it does have a value, it's only 1. What am I leaving out? Any rules that I'm leaving out? If there are any business rules I'm leaving out, and here's what you can do. You can sort of start doing the next step, which is the ERD based on those business rules and based on these tables, and then see when you make the ERD, it can kind of hint at you what you might have left out. So here's the ERD. So here's where the one painter paints at least one, and possibly many paintings. So the many side's over here, and it's mandatory because he has at least one he's painted. And each painting has a painter. So that's why it's the 2 bars. The other bar means mandatory. There are no paintings that have 0 painters. There's no magical paintings. Each gallery, so PH is optional, right? PH is empty, so that's why it's optional over here. Each gallery displays 0 or more paintings. Because some painting, if you look at the galleries, there's several that are SS, so that's many paintings for SS. Smithsonian has several paintings, so that's the many part. And then each painting is in 0 or more galleries, because there's that one that's not in a gallery because it's null in the foreign key, which is perfectly fine. That can be a thing. City of Bones is not presently in any gallery. So that's both things kind of at once. And just make sure you put all the attributes over here on the side, and you correctly do the primary keys and foreign keys. So the foreign keys are only in the paint. This also, if you look at the table again, compare the table to this diagram. Remember the question about foreign keys. What are the foreign keys in each of these tables? Well, this is the only one with FK over here. There's got 2 FKs, painter ID and gallery ID. So you can see, and then the PK, you can see how that's identified for each one. So this goes back. You can double check the chart that you fill out partially. You don't see the stuff about referential integrity that's necessarily directly here, but you do see how the relationships work and what's a foreign key and what's a primary key and all that. And so that bonus question, I don't know if I want to answer it, but the simplest answer that I would give you full credit for is that you create another table between these two, painting and gallery, and and it would be a bridge into me. Now, the question you have to ask is like, what does that mean? Because are you talking about copies of paintings? Or are you talking about one painting? If you're talking about one painting, what I would create is a table. I didn't model this, but I would create a table in between. I'll call it showing, maybe. And I would have three things at least. I would have the gallery ID, the painting ID as foreign keys. So this painting is in this gallery. And then I would have like the start time, the showing start time. So starting on October 1st, this painting will be in this gallery. And maybe the ending date. And then it stops being shown in this gallery on October 31st. And then the same painting can be shown in a different gallery starting at a different date. And then later on, it can come back to this first gallery it was in on a different starting date. So you would have to include at least 3 items for the primary key. We'd have, it's kind of like the second scenario with actually I would just have a surrogate key here too, honestly. But you could combine, say, the gallery ID with the painting ID with the start date, for instance. If the painting doesn't start and end on the same day twice, right? Usually it's just going to be one day. It's not going to be shown in half the day and then go another gallery for part of the day and then come back. That's not going to happen probably. So you could use gallery ID plus painting ID plus start date to make a primary key. You could also throw in end date, but you don't need it because the start is enough to make it a primary key. Or better, cleaner, easier probably is just to have a showing ID as a surrogate key, just one value. So showing number 1 is painter number 1 in gallery BB, and then you would still have the start and end dates and maybe a couple other things. So those are some possibilities. You had to say something about a bridge table for that because it just won't work any other way. But then you'd have to like show your creativity. Like we're talking about prints, so like you could have different painting, the same painting, but prints of it, copies in several galleries at once in the same time. That's a reasonable answer. You do have to speculate a little bit, so that's why I didn't like that one. I think it makes more sense that like the Mona Lisa is traveling around, so it's in the Louvre. It'll probably never leave the Louvre, but let's say that somebody gets a wild hair and says, okay, let's take it to the Metropolitan Museum of Art in New York for 2 months or something. Then that's how you would have, that's one way you would have to create that table in between that shows how another way, I mean, you could do it, but it did specify multiple paintings or at the same, different, so a painting over several galleries. If it didn't specify that, you could still use this model we have here to update where it's at. So you could have like in the Louvre, and then you update the foreign key to the Metropolitan Museum's foreign key to show that it's changed where it's currently housed. But you don't have to create a new table for that. I hope this is making sense. You could do what I just said with if there's just one painting, one copy of each, there's one print of every painting, there's just the original painting. You could move it around to the different galleries by just updating that foreign key column in the painting table when it moves from one gallery to another. But if you're talking about more than one copy of the painting or the same painting over several galleries in time, that actually doesn't make sense now. But yeah, if you had something about a bridge table in between the two, that would be fine, because the question does specify that it's more than one painting. Let's look at the question. If we want to loan paintings to multiple galleries, describe the changes we must make to our DB to support this. Yeah. So it would have something to do with the table in between. All right. If you have any questions about this, let me know. If you have any questions about again, the first part of the midterm, send me an email or do office hours. But I just wanted to cover this one. The main things in this one that have to do with the bridge tables and the referential integrity and stuff like that, and foreign keys and primary keys, because you're going to need to know that pretty solidly before you start doing normalization. And normalization is just a way to refine and polish each of these tables to make sure the right columns are in the right tables to make your database operate efficiently without data anomalies. So you'll learn more about that as time comes. And that's I hope this was still recording, wasn't it? Pray for me. It's still recording. Yeah, it's recording. All right. So I'll talk to you guys soon about something else.